Hello everyone, in this video I'll be explaining on the topic electron microscope. This electron microscope is also an optical microscope, which is a technique for obtaining high resolution image of biological and non-biological specimens. In electron microscopy, a beam of electrons is employed instead of the beam of light used in optical microscope. It works by where the electron beam is focused by circular electromagnets, which are analogs to the lenses of light microscope. Shadow casting is an important technique in electron microscopy. This is achieved by depositing a thin layer of metal on the object. Such metal-coated object held in the path of the beam scatters the electron and produces an image which is focused on a fluorescent viewing screen. There are two types of electron microscope: a scanning electron microscope and transmission electron microscope. Coming to the principle of scanning electron microscope, a scanning electron microscope is a type of electron microscope that produces images of a sample by scanning the surface with a focused beam of electrons. The electrons interact with atoms in the sample, producing various signals that contain information about the surface topography and composition of the sample. The scanning electron microscope is a recent development which provides a higher resolution and three-dimensional image of the electrons. Specimens are observed in high vacuum in conventional scanning electron microscope or in low vacuum or wet conditions in variable pressures or environmental scanning electron microscope and at a wide range of cryogenic or elevated temperatures with specialized instruments. The beam of electrons or the electron beam is scanned in a scan pattern, and the position of the beam is combined with the intensity of the detected signal to produce an image. In the most common scanning electron microscope mode, the secondary electrons emitted by atoms excited by the electrons beam and detected using an Everhard-Thornley detector. The number of secondary electrons that can be detected and thus the signal intensity depends, among other things, on specimen topography. The scanning electron microscope can achieve resolution better than 1 nanometer. The signal used by a scanning electron microscope to produce an image results from interactions of the electron beam with atoms at various depths within the sample. Various types of signals are produced, including secondary electrons, reflected or backscattered electrons, characteristic X-ray and light carbon illuminescence, absorbed current, that is specimen current, and transmitted electrons. Secondary electron detectors are standard equipment in all scanning electron microscopes, but it is rare for a single machine to have detectors for all other possible signals. This is how it appears under the microscopic view under the scanning electron microscope. So this is how it looks under the scanning electron microscope of various microorganisms, the bacteria, the virus. And this scanning electron microscope is in addition to topographical, morphological, and compositional information. A scanning electron microscope can detect and analyze surface fractures, provide information in microstructures, examine surface contaminations, reveal spatial variations in chemical compositions, provide qualitative chemical analysis, and identify crystalline structures. The scanning electron microscopes can be as essential research tool in fields such as life science, biology, germology, medical and forensic science, metallurgy. So this is about the scanning electron microscope of electron microscope.